All right, good morning. Today we're going to look at the solution chemistry. Here we're going to talk about the chemistry of dissolving, breaking apart, forming ions, forming compounds, and then the solubility rules.
Solubility is defined as the ability of a compound to dissolve in a solvent. Here, we will consider water to be the solvent.
Different compounds have different solubility in water.
For example, sodium chloride dissolves in water and we say it is soluble.
Whereas calcium carbonate has very limited solubility and we say it is insoluble.
The next table explains the solubility rules for chlorides, bromides, and iodides. When you click chlorides, bromides, or iodides, the respective solubility rule appears.
So we're going to look at the chlorides, bromide, and iodide solutions and solubility and know which one of the chlorides or bromides or iodide are soluble.
All chlorides are soluble except silver, mercury 1, lead, and copper 1 chlorides. All bromides are soluble except silver, mercury 1, lead, and copper 1 bromides.
Now, did you see the pattern? Some specific elements are just not soluble when they form chloride or bromide or iodide solution.
All iodides are soluble except silver, mercury 1, lead, and copper 1 iodides.
So in this case, it means you can memorize all those four that are insoluble with the chlorides, bromide, and iodide. There's a pattern there.
The next table requires your interaction to form compounds. For group 1 and group 2 elements, click on any metal, then click on any one anion. This forms a compound. Then see the compound dissociate into ions if it is soluble in water.
For transition elements, click on metals that are highlighted in yellow. Transition elements with different charges appear. Click on the charge that you want, followed by clicking the anion. This would form a compound. Then see the compound dissociate into ions if it is soluble in water.
All right, we are going to pick one of the group 1 elements combined with the chlorides.
Na plus 1 sodium ion.
Cl minus 1 chloride ion.
Sodium.
Chloride.
Na
Cl is soluble in water. When dissolved, it breaks down into
Na plus aqueous.
Cl minus aqueous.
All right, let's pick another group 2, another one from group 2.
Mg plus 2 magnesium ion.
Br minus 1 bromide ion.
Magnesium.
Bromide.
Mg.
Br2 is soluble in water. When dissolved, it breaks down into
Mg plus 2 aqueous.
2Br minus aqueous.
Now, remember that bromide has a negative one ion, but when you're writing the ionic equations, remember this is the tool to balance the two ion from magnesium or two extra electrons being donated by magnesium. That means you have two bromide ion from the formula of MgBr2. So when you want to balance that equation, that two must be a coefficient. There is nothing like Br minus 2. It has to be 2Br so that the two negative and the two positive will balance each other. All right? And eventually they will cancel out when they form a compound. Well, let's take one of the transition mirror. Let's take titanium.
Ti
Titanium 3.
plus 3 titanium ion.
Let me add iodide to
I
it.
minus 1 iodide ion.
Titanium. Roman numeral 3.
Iodide.
Ti
I3 is soluble in water. When dissolved, it breaks down into
Ti plus 3 aqueous.
3. I minus aqueous.
Remember, the 3 comes from 3 iodide, that is picking the 3 electrons from titanium. All right, and this aqueous is always written for ionic equation because this is in water. That means the substance are dissolved in water. Anything dissolved in water becomes an aqueous. Right, let me pick one of the transition mirror again and see whether you still remember our solubility rules from the previous page. Picking silver. And let me add chlorine to it.
Cl minus 1 chloride ion.
Ag plus 1 silver ion.
Cl minus 1 chloride ion.
Silver.
Chloride.
Ag
Cl is
Insoluble.
in water.
So therefore, it does not dissociate. So this is going to stand together as AgCl2 solid. It's still together. It's not soluble in water. It doesn't dissolve. So it remains as a precipitate. If it dissolves, then it becomes aqueous. Plus, it is Ag aqueous and Cl aqueous. But since it's not soluble, the solid will remain solid. And this is what you're going to use when you are writing your net ionic equation. We'll get there. This is just introduction to that. All right, let's take one more example. Let me click on zinc.
Zn plus 2 zinc ion.
And let's pick chloride.
Cl minus 1 chloride ion.
Zinc. Roman numeral 2.
Chloride. When dissolved, it breaks down into
Zn plus 2 aqueous,
2Cl minus aqueous.
The next table explains the solubility rules for acetates, chlorates, perchlorates, nitrates, and hydroxides. When you click acetates, chlorates, perchlorates, nitrates, and hydroxides, the respective solubility rule appears.
All acetates are soluble in water.
So that's a good one. You don't have to remember anything that all acetates are soluble.
All chlorates are soluble in water.
Another good one.
All perchlorates are soluble in water. All nitrates are soluble in water.
What about hydroxide?
Group 1 hydroxides are soluble in water. Calcium, strontium, and barium hydroxides are slightly soluble in water. All other hydroxides are insoluble in water.
Remember that. Group 1, they are all soluble. Let me go back
Group
again.
1 hydroxides are soluble in water. Calcium, strontium, and barium hydroxides are slightly soluble in water. All other hydroxides are insoluble in water.
So that means your calcium, which is in group 2, your strontium, group 2, and barium is also in group 2. The hydroxide are slightly soluble, but any other hydroxide is insoluble. So that means you have copper hydroxide, zinc hydroxide, iron hydroxide, manganese hydroxide, every other one hydroxide is going to be insoluble, except all group 1. That's why we use sodium hydroxide, potassium hydroxide in the lab more often because they are soluble.
The next table requires your interaction to form compounds. For group 1 and group 2 elements, click on any metal, then click on any one anion. This forms a compound. Then see the compound dissociate into ions if it is soluble in water.
For transition elements, click on metals that are highlighted in yellow. Transition elements with different charges appear. Click on the charge that you want, followed by clicking the anion. This would form a compound. Then see the compound dissociate into ions if it is soluble in water.
So the question is, if I click, let's do some interactive. If I pick potassium plus perchlorate ion, is this soluble or insoluble? If you say soluble, that's correct. Remember, all group 1 elements are soluble hydroxides.
Na plus
ClO3 minus 1, chlorate ion.
Sodium.
Chlorate.
Na
ClO3 is soluble in water. When dissolved, it breaks down into
Na plus aqueous
ClO3 minus aqueous.
All right, let's pick group 2 elements. Let's pick
Mg
magnesium.
plus 2 magnesium ion.
So if I add that to nitrates, what do you expect? Soluble or insoluble?
NO3 minus 1, nitrate ion.
Magnesium.
Nitrate.
Mg
Parentheses.
NO3
2.
is soluble in water. When dissolved, it breaks down into
Mg plus 2 aqueous
2
NO3
minus aqueous.
Okay, let me pick transition mirror. Ion 2.
Fe plus 2 iron ion.
Let's see hydroxide.
OH minus 1, hydroxide ion.
Is this soluble or insoluble?
Iron. Roman numeral 2.
Hydroxide.
Fe
Parentheses.
OH
2.
is
Insoluble.
in water.
Remember the hydroxide? All these transition mirror with hydroxide are insoluble. This OH is only soluble with group 1 and slightly soluble with MgC and SR. Now let me pick aluminum.
Al plus 3 aluminum ion.
If I combine that with nitrate, what happens?
NO3 minus 1, nitrate ion.
Remember nitrates?
Aluminum.
Nitrate.
Al
Parentheses.
NO3
3.
is soluble in water.
Remember all nitrates are soluble.
When dissolved, it breaks down into
Al plus 3 aqueous
3
NO3
minus aqueous.
Now remember when you're writing ionic equation, when you're breaking down compounds like this. At the beginning, remember these three came from aluminum. All right, because when they were in ionic form like this, NO3 minus, what happens? There was a crisscross. These three comes here, and these two goes, and this one goes here. So you have Al1 and NO3. Remember, this is nitrate. The formula doesn't change. So these three, which is the charge on the aluminum, comes down to nitrate. That's why you have Al parenthesis NO3 parenthesis 3, just like you have right here. And when they break down, they go back to where they come from. It's like a reverse reaction. Just remember that. That will help you a lot.
The next table explains the solubility rule for sulfides. When you click sulfides, the solubility rule appears.
You have to remember these rules as well.
Group 1 sulfides are soluble in water. All other sulfides are insoluble in water.
Remember that rule.
The next table requires your interaction to form compounds. For group 1 and group 2 elements, click on any metal, then click on any one anion. This forms a compound. Then see the compound dissociate into ions if it is soluble in water.
For transition elements, click on metals that are highlighted in yellow. Transition elements with different charges appear. Click on the charge that you want, followed by clicking the anion. This would form a compound. Then see the compound dissociate into ions if it is soluble in water.
Remember all sulfides are soluble. So
Na plus 1 sodium ion.
all group 1 sulfides are soluble except other ones, other groups that are not soluble.
S minus 2 sulfide ion.
Sodium.
Sulfide.
Na2
S is soluble in water. When dissolved, it breaks down into
2 Na plus aqueous.
S minus 2 aqueous.
What about group 2?
Ca plus 2 calcium ion.
S minus 2 sulfide ion.
Calcium.
Sulfide.
Ca
S is
Insoluble.
in water.
What about transition?
CO plus 3 cobalt.
S minus 2 sulfide ion.
Cobalt. Roman numeral 3.
Sulfide.
CO2
S3 is
Insoluble.
in water.
Remember the rule. All group 1 metal is soluble, so it's soluble with sulfide solution. They are all soluble sulfide compounds. Any other group would not dissolve in water.
The next table explains the solubility rules for carbonates, chromates, and sulfates. When you click carbonates, chromates, and sulfates, the respective solubility rules appear.
Group 1 carbonates are soluble in water.
All other carbonates are insoluble in water.
Group 1 chromates are soluble in water.
All other chromates are insoluble in water. Most sulfates are soluble in water except calcium, strontium, barium, radium, mercury 1, and lead sulfates.
So these are the solubility rules for carbonates, chromates. They are all soluble. They have group 1 solubility. It's like they are in love with group 1. Most of them. They are always soluble in group 1. And they are insoluble with others. I need to take notes of all these things, write them the notes. because you're going to use the knowledge you acquire from here when you get to net ionic equations. So that is the only way you know which one is soluble, which one is insoluble. Just remember these rules. And know that we are not going to be given this on the periodic on the formula sheet. You have to memorize these solubility rules. Know which ones are soluble, which ones are insoluble.
The next table requires your interaction to form compounds. For group 1 and group 2 elements, click on any metal, then click on any one anion. This forms a compound. Then see the compound dissociate into ions if it is soluble in water.
For transition elements, click on metals that are highlighted in yellow. Transition elements with different charges appear. Click on the charge that you want, followed by clicking the anion. This would form a compound. Then see the compound dissociate into ions if it is soluble in water.
All right, you know we're familiar with all this, carbonate, chromates, and sulfates. So by now you should be able to tell me exactly which of them will be soluble, which of them is insoluble. All right. So if I pick lithium,
Li plus 1 lithium ion.
chromates.
CrO4, -2, chromate ion,
Lithium.
chromate.
Li2
CrO4 is soluble in water. When dissolved, it breaks down into
2 Li plus aqueous.
CrO4, -2, aqueous.
Remember, if it is not soluble, they will not break down. They will remain intact. Okay? Let's try vanadium 5.
V plus 5 vanadium ion.
With sulfate.
SO4, -2, sulfate ion.
Vanadium. Roman numeral 5.
Sulfate.
V
Parentheses.
SO4, 2. When dissolved, it breaks down into
All right, let me take one more.
Hg plus 1 mercury ion.
How about carbonates?
CO3, -2, carbonate ion.
Mercury. Roman numeral 1.
Carbonate.
Hg2
CO3 is
Insoluble.
in water.
Remember the peculiarity. Remember there was a pattern that you must have observed when we were doing the other solubility rules. So you need to take down notes and remember this pattern.
All ammonium compounds are soluble in water. In the next table, ammonium ion along with several anions are shown. Click on ammonium ion, then click on any one anion. This forms a compound. Then wait to see the dissociation of the compound into ions.
Now, I would advise you take down notes. Don't just rely on this video. Remember your exams, you will not have access to this video and you will have access to the internet. So I would advise you get your notebook and jot down these bullet points so that it will be a handy review for you when your exams is around.
C2H3O2 minus 1, acetate ion. C2H3O2 minus 1, acetate ion, is soluble in water. When dissolved, it breaks down into
NH4 plus aqueous
C2H3O2
minus aqueous. S minus 2 sulfide ion.
is soluble in water. When dissolved, it breaks down into
2 NH4 plus aqueous
S minus 2 aqueous.
So try to look at this solubility table with ammonium ion. All right, just remember the carbonate, the sulfate, the hydroxide, the perchlorate, the bromides, chlorides, and all those stuff.
In conclusion, all ammonium compounds discussed here are soluble in water. All compounds consisting group 1 elements or alkali elements are soluble in water.
All right, so let's do our practice now. We're going to practice solutions. Compound CrCO3, the name of the compound is what? Type your answer. All right, I'm going to provide the worksheet on this one so that you can easily type your answers. This is going to be the end of the solubility rules. So go back and review the video properly so that we can do more practice on that when the time comes. Thank you.